before we have a look at some questions, there's just one thing that I want to make clear that I don't think I've really covered so far. So I'm going to draw the electron configuration for fluorine using my energy diagram. Fluorine's quite a simple one. There's only 9 electrons to assign. And I know from previous diagrams that I have got one s orbital as my lowest energy. Then I've got a 2s orbital. And then I've got 3 2p orbitals. I've got a 2px, a 2py, and a 2pz. And when I'm putting electrons into my orbitals, I will always start with the lowest available orbital. So the 1s is the lowest in energy. So the first 2 electrons I'm going to put into the 1s orbital. When my 1s orbital is full, only then will I move to the 2s orbital, which can again hold 2 electrons. So I have 9 electrons to assign in total. I've already assigned 4, which means I've got 5 electrons left to fit into my 2p orbitals. Now, when I'm putting these 5 electrons in, there's a rule I need to remember. And that rule is that electrons will fill orbitals singly before they start filling them in pairs. Now, this rule is only true if you've got available orbitals that are all of the same energy. So here, the 2s is lower than the 2p. So I fill the 2s completely before moving to the higher 2p. But when I get to the 2p level, I've got 3 equivalent 2p orbitals. Rather than putting 2 electrons in the 2px right from the start, what the electrons will do is they'll spread themselves out as much as possible. Then, if they have to, they'll go back and they'll pair up. So I've assigned 4 electrons. I've got another 5 to go. I'm going to go 1, 2, 3. Okay, so if I'm filling those 5 electrons in, I'm going to put them individually into 2px, 2py, 2pz. I've still got 2 electrons left. Then I go back and put another one with px, another one with py, and I don't have to pair up pz. The reason the electrons would rather be by themselves, if that was an option, is because electrons are negatively charged. So they're all going to repel each other and they want to be as far from each other as possible. Having said that, the electrons aren't going to start filling in the 3s orbital while there's still space in the 2p. Okay? They will totally fill up an energy level before moving to a higher energy level. But if they have the option, they will fill them individually before filling in pairs. This is probably best seen with something like carbon. It's actually a little bit easier. So if I have carbon, again, I've got 1s, I've got 2s, and I've got 3 2p's. I've got 2px, 2py, 2pz. Carbon has got 6 electrons in total. Okay, it will totally fill the 1s orbital, and then it will move to the 2s orbital, and it will totally fill that. But when I'm putting it into the p orbital, instead of putting both of those electrons in 2px, because the 2py is equivalent to 2px, you'll go 1 in 2px, 1 in 2py. If you were to do nitrogen, nitrogen has 7 electrons. You would put that 7th electron into 2pz. Only when they're all occupied singly will you then go back and occupy them in pairs. We're now going to go and do some questions. So if you have got the booklet, I have an exercise on page 6. So exercise 2 on page 6. I ask you just write, so there's no drawing required, just write the electron configuration of the following atoms. In the first question, I instruct you to separate out the p orbital. So tell me if it's 2px, 2py, 2pz. In the second, you can just lump those p orbitals together and tell me how many electrons in total are in the p orbitals. And in the third, I want you to use the noble gas. So to see how to do that, just scroll up here to shortcut 2 and it will explain it. Have a go yourself. I'm going to go through all of these answers in the video anyway, but do have a go yourself before checking my answers. So the first question, and exercise 2 on page 6, is just fluorine. And if I want to write the electron configuration for fluorine, it's got 9 electrons. It's going to be 1s2, 2s2. And I told you to separate out the p orbitals into 2px, 2py, 2pz. I'm going to have 2, 2, and 1. 2, 4, 6, 8, 9 electrons in total. The next one I asked you to do is neon. Neon is just one up from fluorine. So I'm going to have 1s2, 2s2, 2px2, 2py2, 2pz2. Then I asked you to do sodium, and this time I said you could put all of your p orbitals together. So I'm going to have 1s2, 2s2, 2p6. That's 2 and 6 is 8 and 2. That's 10 electrons assigned. And then I've got 3s1. Then I asked for magnesium with 12 electrons. 1s2, 2s2, 2p6, 3s2. Aluminium with 13 electrons, so I'm going up in order. So I know all of this is going to be exactly the same as the one before, but I have an extra electron after 3s. Where do I go? I go to 3p, and I've got 1. And then I ask you for silicon. So again, doing out silicon, I'm going to write exactly the same as aluminium, but I'm going to have 2 electrons in the p orbital, not just 1. So relate this back to what we've seen at GCSE in terms of the periodic table. Fluorine is in group 7. If you look at the second electron shell, you have got 2, 4, 6, 7 electrons, and you've got 2 shells in total, 1 and 2, because fluorine's in period 2. With neon, okay, it should have a full outer shell. Its outer shell is second shell, 2, 4, 6, 8, and it's got 2 shells in total. It's in period 2. Sodium's in group 1, and its outer shell is a 3s1. You've got 1 electron in the outer shell. You've got 1, 2, 3 electron shells in total. Magnesium also has 3 electron shells. So does aluminium. So does silicon. They've all got 1, a 2, and a 3 because they're all in period 3. Magnesium's in group 2. It's got 2 electrons in the outer shell. Aluminium's in group 3. So it's got 2 and 1 is 3. Silicon's in group 4. It's got 2 and 2 is 4. So it is consistent with what we would have seen at GCSE. I then ask you to do a few more using the noble gas. So for phosphorus, okay, phosphorus is 15, okay? What you've seen here is we're writing it the same thing over and over and over again. If I was to do phosphorus, I'd write this whole thing out all over again, and I'd just add an extra electron, and I would end with 3p3. It gets a little bit tedious. So rather than writing this out all over again, the only electrons I'm ever interested in are the outer shell electrons. So instead of writing 1s2, 2s2, 2p6, I'm just going to replace that with the noble gas. Okay, so phosphorus is here in period 3. The noble gas in the period above phosphorus is neon. And we've already seen that neon has the electron configuration of 1s2, 2s2, 2p6. So rather than writing all of this out, I'm just going to write neon in square brackets. And that neon fills in for this whole part of the electron configuration. That allows me just to focus on the outer shell, which is what's important. So for phosphorus, okay, it's in group 5, I've got 5 electrons in the outer shell. I'm going to have 3s2, 3p3. Okay, so you can see I've just added 1 electron to what I had for silicon. I've gone from 3s2, 3p2 to 3s2, 3p3, and I've just avoided writing all of this out by putting in neon instead. The next one I asked for was sulfur. I'm going to do exactly the same for sulfur. I'm going to use neon. I'm just going to focus on the outer shell, which is the third shell, which is going to be 3s2, 3p4. 2 and 4, 6 electrons in the outer shell. Sulfur is in group 6. Then I do chlorine. I'm just adding 1 extra electron, so I'm writing neon, 3s2, 3p5. 2 and 5 is 7 electrons for chlorine. And then I am doing argon, which itself is a noble gas. So I'm going to write out neon, and then 3s2, 3p6. 2 and 6 is 8. Argon has a full outer shell. I then move down to potassium. So when I get down to potassium, I've moved from period 3 down to period 4. So if I want the noble gas in the period above potassium, I'm going to be using argon. Okay, so rather than writing out everything, I'm just going to write argon, and I'm only going to focus on the outer shell. And for potassium, it's going to be 4s1. That gives me 1 electron in the outer shell, which is what I expect for potassium. If I do calcium, I'm going to do exactly the same. I'm going to use argon from the period above, and now it's going to be 4s2. 2 electrons in the outer shell, what you expect for a group 2 element. Then I do scandium. So we never would have done scandium at GCSE. It's one of our transition elements. It's next to calcium. So I'm going to use argon. Okay, and if we remember, after the 4s orbital fills, then the 3d orbital fills. So it goes 3s, 3p, then the 4s, and then back to the 3d. So you're going to have a 3d orbital, and then you're going to have a 4s orbital. For scandium, you're going to have 2 electrons in there, and then the third electron is going to go in there. The next one I asked for is titanium, which is next to scandium. So you're going to have your argon again. You're going to have a 3d. You're going to have a 4s. That 4s is going to be full. That extra electron goes into the 3d. And then I ask you for vanadium, which is going to be Ar. I have a 3d and I have a 4s. 2 electrons in there, 3 electrons in there. Okay. If you're getting slightly confused with these guys, then it is worth drawing the whole thing out in full, and you can see exactly what's going on. So in the minute I've got left in this video, I am just going to draw out vanadium for you in full, so you can see all of the different energy levels. So if I draw out vanadium, I'm going to have my 1s, then I move on to 2s, I've got my 3 2p's, then I move on to 3s, and my 3 3p's. Then I know I've got my 5 3d orbitals, but slightly lower in energy than that. I have got my 4s, and then above my 4s I would have my 3 4p. So that's what it would look like in total. With vanadium, I've got 23 electrons to assign. So I'm going to put the first one, the second one, first one, the second one. Then I'm going to go 1 2 3. I'm going to fill those individually. Then I'm going to fill them up in pairs. Then I'm going to do the 3s. Then I'm going to do my 3p individually, fill it up in pairs. Then I'm going to go to the 4s because that's after 3p. And I've now assigned 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 electrons. I've got 23 to assign. So I'm going to fill them into my 3d. And I'm going to go 1, 2, 3 because they're all equivalent in terms of energy. And they will fill singly before filling in pairs. And this is what vanadium would look like if you drew it out. But when you're just writing the electron configuration, it looks like this. If you're finding these difficult, draw them out in full until you get more used to it. And then you can use shorthand to make it quicker.